Welcome to Algebra 2 Regents Review with Miss Kempton. This is our Do Now number 1. Okay, so for question number 1, we have this sketch and we want to know what can be the equation. So what we have here are zeros. Zeros are what crosses the x-axis. You're always looking for the opposite when you're writing your factors. So in this case, if this is a minus c, you're looking for x plus c, x plus b, and x minus a. So just knowing that information, choice 2 is out and choice 3 is out. Now also we have here what's called a bounce. A bounce is when it kind of bounces off the axis and then goes in the same direction. So a bounce is going to have a squared at the factor, and there is your squared right there, so your answer is choice 4. Okay, moving on to your second one. You technically can do this question without actually doing work. We're given a function we call p of x, and we want to know which statement is true. So we have the words factors here. Factor means that when you plug a number in, you're going to get 0. So just knowing that, they're telling you that this is equal to 2. That's impossible, because if it's a factor, it's supposed to be equal to 0. Okay? Equal to 0, equal to 0. Now another thing we also know is that you're always substituting in the opposite number. So if this is x plus 1, you should be substituting in negative 1. So that is impossible there, so that does not work. Where you'll notice here, x minus 1, you'll be substituting in the opposite, which is positive 1, which does work. Therefore, the answer is choice 4. And our last question for today, I'm actually going to be doing this 2 ways. I'm going to show you the shortcut using your calculator, and then I'll show you the long way how to do it, and hopefully both work out. So there are a couple different ways that you could do this. One way is you can actually store each answer in. Another way, which I learned recently, is for each side of the equation, the left side and the right side, you can actually substitute into your calculator and then look at your table to see where they're the same. So on the left side, I have x, and on the right side, I have the square root of 3x plus 40. Okay, now if I graph this, wonderful, I could see it. That is technically where my intersection is. You could see it there, but if we want to actually look at the table, okay, let me go to my table set that at 1. All right, and if you notice, when x is 8, we have 8 here and we have 8 here. So therefore, whenever the y's are the same, the answer is going to be whatever the x is. So our answer should be positive 8. Okay, if we look closely, when we looked at the negative 5, we had a negative 5 here and a positive 5 there, so that did not work. And if we scroll more, none of the other y's are the same. Okay, now if we were to do this the long way, the rule is first isolate your radical and then square both sides. So luckily our radical is already alone on the right side of the equation. So now we're able to square both sides to get rid of the radical. I call this the jewelry box method because we want to unlock the jewelry box. Now, when we unlock the jewelry box, nothing happens inside. We're just able to get to our jewelry. All right, now I have an x squared on the left side. I have a 3x plus 40 on the right side. Because none of them are like terms, I'm going to go ahead and move over everything to one side so that I could set it equal to 0 to solve. So now that I have my equation on the left side, I can go ahead and factor. So I'm going to break up my x and my x. my first sign I'm going to drop down. The next one, I'm going to multiply a negative times a negative to get a positive. And now lastly, I'm looking for numbers that multiply to 40. So my numbers that multiply to 40, or 40 times 1, 2 times 20, what else do I have? 4 times 10, and 8 times 5. Whatever two I choose, when I write them down, larger one goes first. They should add to the middle number, which is -3. So this is correct because a -8 plus 5 is a -3. Once I have each of these, I'm going to set them both equal to 0. So therefore, I'm going to get 8, and I'm going to get -5. Now this is where you have to be careful though, because if this was what our original answer was, we would have said that 1 was correct. But the reason why 1 is not correct is because you always have to check. So if we check the original, x, which is 8, is equal to 3 times 8 plus 40. This is equal to the square root of 64, which is correct. But if I check -5 and I check the original equation, I would get the square root of 25, and the square root of 25 is +5. So that does not work, leaving me only 8 as a solution. Thank you for joining.